guys, welcome to the next video. Okay, welcome to the next video. We are talking about osmotic solutions. As you already know, watch the video, take notes over the video, pause and rewind as needed. Your notes can be over what's heard and what you see on the screen. And of course, you'll be taking an interest quiz the next school day. So let's go ahead on to the first slide. Hey. Okay, so I want you guys to look at this right here. So you see the different names. There's hypotonic, isotonic, and hypertonic. Again, hypotonic, isotonic, and hypertonic. I actually want to give you about 20 seconds to look at this. And on your paper, I want you to write down these 3 words, and I want you to tell me what you see happening. So I'm actually going to be quiet for like 20 seconds. It's going to be weird. And I want you to write down your observations. Go. Awesome. So hopefully you guys had some good notes written down. That was kind of creepy, actually. Okay, so I just want to go back. What do you notice happening? We see in a hypotonic, what is the cell doing? It's swelling. And where is the water going? The water is going inside the cell, which is causing it to swell. What about isotonic? What did you see? We've seen that as one water entered, another one exit. And did the shape ever change? Nope. It didn't. And then we have hypertonic. So we see that water is actually leaving out of the cell. And what is it causing the cell to do? Shrink. So this is actually good because you already have basically taught yourself half of the notes today. It's an awesome job. All right, so here are some words I want you to write down that you're going to see, and I want you to make sure you understand it. So I want you to write down the word and the definition and draw the picture. So the first one I want to point out is solute. Say that with me, solute. Awesome. So solute are the particles. So I want you to think about if we were making Kool-Aid. What's your favorite kind of Kool-Aid? Grape, strawberry, raspberry? Do y'all like mixing them? I know I like mixing them. Anyways. All right, so the little packet of Kool-Aid, the little crystals will be the solute. And examples of solutes that our cells will need, because our cells don't need Kool-Aid, they need sodium, and they need glucose, and they need all other kind of particles. So the solute will be the little particles here. Then we have solvents. Solvent. So the solvent is the liquid, which majority of the time is water. So here's the solvent, and then the solution is all of it combined. So this whole thing is solution. You're going to need to know this, guys. So solute is the particle. Solvent is the water. Solution is the whole thing put it together. I wanted that to rhyme, but it didn't. Okay. So the first solution we're going to talk about is isotonic. That was the one we seen where the cells stayed the same, where one exited and one entered. So the word iso means same or equal, which makes sense because it stays the same. All right, so basically isotonic is when the solute concentration inside the cell is equal to the solute concentration outside the cell. So look right here. This is what I mean. Right here we have how much sodium, because remember, sodium is the solute. So we see that the sodium here is 3% inside the cell, and then in the solution it's also 3%. So that cell is going to say the exact same. I want you to draw this diagram and with the numbers as well. All right, so the next one we're going to talk about is hypotonic. I like to think hippo, because what does a hippo look like? Boom, it looks swole, it looks fat. Like, look how cute this one looks. He's so cute. Anyway, so we have hippo. So you can guess the hypotonic one is the one that swells. So why does it swell? Well, the solute concentration, so how much solute is inside of the cell is greater than how much solute is outside of the cell. Here is the key statement I want you to remember for this topic. Water moves to the highest solute. 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 Twerk it with me, twerk it with me. Guys, I need you to remember that. Water moves to the highest solute. So what does that mean? That means wherever there's the most particles, the water wants to move there because it's way too flooded. Let me ask you this. What happens when you put way too much sugar inside of your Kool-Aid? What do you have to do? Yep, because I know y'all made Kool-Aid before. You usually add more what? Water. Why? So it can dilute it. So it can make it less strong or less sweet. It's the same here. Your cell doesn't want to have a super big amount of solute. So it wants to make sure that what's inside of the cell is equal to what's outside. So it's going to add water to wherever there's the most solute or particle. So let's look here. This cell has 3% sodium. This one has 1% sodium. Where's water going to move? To the highest solute. So the water, look how much water there is here. Since there's enough water here, water is going to begin to move inside of this cell because there is too much solute there. So when the water moves into the cell, what is the cell going to do? That's right. The cell is going to begin to swell. Now, what happens if too much water goes in? What's going to happen to the cell? What do you think? That's right. It's going to rupture. It's going to burst. Okay? So, again, water moves to the highest solute. In hypotonic, there is a lot of solute inside the cell. So since there's a lot inside of the cell, the water is going to move inside of the cell, which is going to cause that cell to swell. Make sure you draw this picture. All right, so the last one is hypertonic. Oh my gosh, you know how you have like those hyperactive students? Maybe I'm thinking about this. Miss Ma, do you agree? She ain't here, but let's say she was. The hyper kids, I like to think if a kid is really hyper, they're like really small because they're always up moving around, okay? So hypertonic shrink. Hypertonic, it shrinks or shrivels because they're like the skinny kid, all right? So what happens here is that the solute outside of the cell is a lot higher than inside. So water moves to the highest solute, which means water is going to move out. So let's look right here. The solute in this scenario is NaCl, which is actually table salt. So we have 3% sodium chloride in the cell, 5% sodium chloride in the solution. So which one has the most solute? The solution. So because the solution has the most solute, where is water going to move? To the highest solute, which means it's going to move to the who? Solution. So look how much water is inside the cell. The excess water here is going to move out of the cell to the solution because it has the highest solute. And when it moves out of the cell, what's going to happen to the cell? It's going to shrink. See, isn't it making sense? I hope it's making sense. If it's not making sense, I need you to replay this part over. Replay it when I went to hypotonic because I need you to understand why it swells and shrinks. This is why. Make sure you draw this picture. All right, so this last part, well, two more slides. You have plasmolysis. Plasmolysis. So basically, this is like the hypertonic of plant cells. So hypertonic in animal cells, what does hyper do? It shrinks, because that's like the skinny kids, they're hyper, so they small. So how the cell shrinks in hypertonic, plasmolysis is how the cell shrinks in plant cells. And basically, the cell is shrinking because it doesn't have a lot of water. So if you look right here, look how much water is inside the cell. And look how much water is outside. Because there's not a lot, what's going to happen to the plant? It's going to die. I have a cactus. Dead as a... I'm going to show y'all. Hold on. Okay, look at my cactus. Look how dead. Like, I didn't know cactus could die. I mean, bruh. They barely need water. But I obviously didn't do my job because look at how dead this thing looks, okay? So this is plasmolysis. Why? Because the cell is shrinking because there's not a lot of water inside of the plant cell. So I want you to make sure you draw this picture because there's going to be a question that's going to make you want to identify this picture. And you have to know that, oh, this is where the plant cell doesn't have a lot of water. This last one, ooh, I really want you to write this down. Okay, fun fact. So, Have you ever went to a grocery store and they were misting the vegetables, or like they had the machine that like sprayed the water on them? Well, actually, they do this because the waters are gonna fill the vacuoles, and due to osmosis, and of course it's gonna make them look fresh. So here it is right here. This is a full vacuole, and here the vacuole is not full. So they do that so that the vegetables can look more fresh. Make sure you write that down. And that is all for today, guys. Thank you for sticking in with me through the solutions video. You the bomb, dig. If you have any questions, comment below so that I can answer them. Subscribe to my channel, because you know, so you can know when more videos come out. And yeah, that's all. All right, kids. Hope you get it. Remember, you do have an interest quiz the next school day over this material. So if you didn't understand something, go back, listen to it again, because that's a luxury of having me on video. All right. Have a good day. Bye.